Okay, so we were looking at the while statement, that the while statement has this syntax where it's a while followed by the expression which should evaluate to true or false. And as long as this statement is true, this is going to be executed. It's going to be executed the first time. Again, it will check, the SQL server will check. If this is true, still true, it will execute this set of commands. Again, it will come back and check if this is still true, it will execute them, and so on. So there is a catch here. When you are using while loop, you should always make sure that your condition is such that it will be changing. Otherwise, you are going to enter an infinite loop. So the common practice is to use a counter or to set the condition such that at some point, this condition is going to be false, in which case this is not going to be executed. Okay. Let's start with a simple example, then we look at another one or two other examples. Okay. You may want, like I said, to loop through and maybe print numbers as long as the counter is below a certain value. Okay, so I'll say I'll declare a variable which I would call, say, counter. And this is going to be an integer. And here you can declare a variable and in the same line assign it a value. Or you can first declare the variable and then at some point you use the set command to assign it a value. Okay. Then I'll say wow, this counter is less than or equal to 10. I want to perform to print something on the screen. So because I'm going to use more than one statement, I have to use the word begin. Then I say print. So counter is and I'm going to concatenate. And because if you remember, we talked about concatenation in some earlier chapter.
Yes.
I need to convert what the number to a string, otherwise I'll get an error message. So I'll say convert. I want to convert to a voucher. And what I'm converting is counter. Then access set counter equal to counter plus 1. Then end. What I'm doing here is that I want first to set this value. I've set it to 1. So the first time it's going to check 1 is less than or equal to 10. This is going to be true. So it will begin, it will print that. The next is going to increase the value which is in counter is going to add a 1. So that now it's going to be 2. And then it will end, to go to the end of this, and then begin, go back to the top to wow, and check if counter is still less than or equal to 10. And since 2 is less than or equal to 10, it's going to perform this. It's going to execute this statement. And after that, it's going to increase the value by 1 so that now it becomes 3. So it will keep increasing after each cycle until the value, when it's 10, when counter is 10, it's going to add a 1 and it will become 11. When it tries to come back to this, the top of the while statement, it's going to find that 11 is not equal to 10, is not less than or equal to 10, in which case it's going to stop the loop. Is that okay?
Yes, sir.
Okay.
Sir, can you just repeat what you just said, please, sir?
What I'm saying is, I want to start with a counter which is set to 1. I can set it to 0.
Okay.
And then here, I'm going to check whether the value of counter is less than or equal to 10. But since 1 is less than or equal to 10, which this is going to be true, so it's going to begin and execute this part. Once it has done this, it's going to come to the next one where I'm increasing the counter value by 1.
By 1,
So
okay.
I've used, this is an increment. As you can see, it's the same name of the variable which I've taken, but the way SQL Server is going to understand this statement is as follows. It's going to say, counter currently has a value of 1. So it's going to say 1 plus 1, which is going to be 2. And that will be now the new value of the counter variable. Then when it comes to end, it will go back to the while, to the top of the while statement, and check if the new value of counter is less than or equal to 10. If that is true, since it's true, it's going to again repeat this. And when it comes to this part, it's now going to say counter now is 2, currently is 2. So it's going to add 1 to a 2 to make it 3 and assign that to the variable. Then again, it to execute, to come to the top. This will still be true. So again, it to print this. Again, it will now say counter is 3. So it's going to add a 1 to it to make it 4. And that will become the new variable of the counter variable. Then again, to come to the top and repeat this until you get to number 10, because at number 10, when it has added a 1 to 10, it's going to become, counter is going to become 11. So when it comes here and try to check, it's going to find that the condition is no longer true. Then it will stop the loop. Is that okay? Is that okay? Okay, so example. So, but I hope this is not confusing you. I've declared this variable, and in the same statement, I've assigned it a value. Okay. So it will, like I said, it will keep execute this. Print counter is equal to then this one, which is now 1 the first time. The next time is going to be 2. Next time is going to be 3 until it gets to 10. When it gets to 10, it's going to add 10 plus 1, which is equal to 11. And then when it checks this condition will now be false. Then it will stop there.
Yeah, it's clear. I understand.
Okay.
Yes, sir.
Okay. So the question here is always make sure that you have a condition that is going to be changing, and at some point it should change to false. If you forget this part, then you are going to enter into an infinite loop. It will keep going and going and going, and it will not respond. So if I was to say this is 100, then it's going to be like that. So you can imagine if it keeps going, then the computer is just going to freeze, and it will just be counting until you force it to stop.
Okay.
Okay. Let me also see if I have another example. Okay, any questions? I think what I have are examples for, I think this example for the case. I didn't show you this one. Maybe I can just go over this quickly. This one is another example of a case statement where you have marks for students. 80% and above is A, 70% to 79 is B, 60 to 69 is C, and so on. So,
Okay.
Okay, so for this, it's a slight different way of using the case statement from the one I showed you. Again, just take note. I'm using set, and I've put the set keyword. Are you able to see my screen?
Okay. Yes, it's showing. I can see it.
Okay. So what I'm saying is, for this one, we so we are defining two variables. So I seem to begin. Anthony is saying that he's not able to hear me. Is anyone able to get me?
Yeah, me, I'm getting you loud and clear, sir. Maybe it's the device is using as a fault.
So Anton, please just check your mic and your speakers. Okay. So we have two variables. There's a variable for grade and there's a variable for mark. Okay. Then I set the mark for this example. I'm setting it to 45. I want to see what grade they will be. So, and then once I do that, I'm going to print this information in form of a table. Okay. So,
you're still on this one. I wanted you to clear that place for me. I wanted to eat.
okay.
You can't go to your table.
So the mark is 45, and according to this, we are saying anything less than 50% is F. So if I was to change this to say maybe 67, 7,
Yeah, 20 hours I can enter that.
then 57 is falling in this category between 70, below 70, but equal to 60 or greater than 60. If we were to say 95, that is 8. Okay. Okay, that's about the three constructs. Any questions?
No questions, sir. It's clear. I'm following.
Please take time to go through those examples.
Yes.
So I continue with a PowerPoint presentation. Okay, there's this PowerPoint, this example for the, again, you can go through. Basically here, what I'm doing is I'm using the Adventure Works database. There is a table called Employee Pay History. I want to check where the average rate of pay and to see if that pay is less than 20. If that is true, I want to update it. This is a case where maybe the human resource department decided that they need to adjust size of employees. And maybe the new policy is such that the average hourly salary rate is supposed to be approximately $20.
Okay.
So you need to increase the rate for all the employees until the average reaches $20. But there is also another condition that the maximum hourly salary rate should not exceed 127. So we'll be checking to see that the hourly rate is 20 and does not, the maximum for any employee is not, this is the average, and the maximum should not be more than 120. This is the the query that we have. So the first part from here up to there, that's the condition. It's going to be checking using a select statement here. This is an embedded query. As you can see, I've put it in brackets. It's selecting the average rate and adding a 1 from the employees in the table and checking if that is less than $20. If that is true, then I run the update statement of the employees where for the employees, a column called rate, I'm increasing the current rate, whatever rate a person has at the moment, I'm adding a 1. Okay. Once I do that, I'm also checking to see if the maximum rate of any employee plus 1 is greater than 120. If that is true, then I'll break the cycle. Okay, in which case it means that it's going to skip from here and come to the end. That's the difference between break and continue. But if this condition is false, if this condition is false, then it will continue by going to the top and then executing this. So it will keep executing these statements until we have reached a point where the maximum rate for one of the employee plus 1 is greater than 120. That's when it's now going to stop.
Mine. It's like a black one.
Okay.
Okay. Yes, sir.
Okay. So the next part is handling errors in T-SQL statements, whether it's a batch or a stored procedure. When you execute a query, it is passed. This word simply means checked, to check to see if there are any syntactical errors. That is, errors to do with the syntax. Maybe the table name that you have mentioned doesn't exist, or you are missing a certain keyword. That is done when you type statements in the management studio. But there are certain errors which are not going to be caught when you are typing. These are going to occur when you are executing the query. These errors, which will occur while the query is executing or runtime, are referred to as exceptions. So an exception is an error which occurs in the code during execution. Exceptions in T-SQL can be handled in 2 ways. You can use the try-catch construct or using the raise error statement. So these are the 2 ways in which you can handle errors which occur during runtime. Using try-catch, the try block encloses a group of T-SQL statements. If any error occurs, the statements which you have put there is going to pass the control to the lower part, which you are going to define as cache. This is like the way we normally do things. You say you are not sure whether you can do something, then you say, oh, no, let me just try. And so you attempt. If you succeed, yeah, well and good. If you don't, then you say, sorry, I couldn't. I think I'm not good at this. Okay. So it's a similar approach where the SQL server will attempt to run the query as it is. But if something goes wrong, then it will stop and go to the lower part, which you have defined as the cache. Okay. The idea is it should not freeze or give some error message. Most of the error messages which are given in SQL Server are meant for people like you and me. So an ordinary user will not understand some of the error messages which are produced, and you don't want them to see those messages. The catch block encloses another group of statements which gets executed when an error occurs in the try block. So you have the try block. Here there will be one or more SQL statements. If something happens there, some error occurs, it's going to stop running and quickly execute this part.
Okay.
Okay. So this is where you would put maybe a more user-friendly error message, a message which can make sense to the person using the database. Okay. The second way of dealing with errors which occur during execution is using the keyword raise error. A raise error statement is used to return messages to the business applications. That is, especially for those of you who are going to be doing software engineering, you are not going to be interacting with the database directly like that. Maybe you are going to be developing some software which will be making use of the database in SQL Server. Now, when something goes wrong, a message can be passed on to the software which is making use of the database. And that's the message that is now going to be displayed to the user of that system. And as you might appreciate, the people who are going to be using those systems are going to be people like people at the teller, the cashiers or people at the till or the managers and directors and so on. So they are not people who are very conversant with the technical aspects of databases. So you want to make sure that when a message is generated, they get something that will make sense to them. Sometimes it could just be that they have entered a value which is not in the database. So you want the database to return a message and pass it on to your application.
Yeah.
Okay.
Okay.
It uses the same message format as a system error or warning message generated by the SQL Server database engine. It can also return user-defined error messages. And this is the syntax. You use the keyword raise error, then in brackets, you put a message which you want to be generated, then the severity, that how severe that error is, and the state of your system. The message, that is this one, that's the text you want to be passed on to the application or displayed to the user of the database. Severity is a
Okay.
user-defined level associated with the message that you are giving them. Some messages will be stop error messages. That is, the system should stop and maybe restart. Some messages are just going to be for information. Other messages are just going to be warning, to warn the user that something has happened, but the system will continue working, and so on. The state, it would take a value between 0 and 255. Now, in IT, you are going to find that this is a very popular number, simply because that's the number which is 2 to the power 8, less than 1.
Okay.
So it just shows it's just an arbitrary range of numbers from 0 up to 255. Those who will be doing networking, you are going to find that IP addresses are going to have 4 components separated by dots, and each part is going to have a value between 0 and 255. It's coming from that aspect that a byte, a binary digit consists of 8 characters, which is given byte 2 to the power 8, which is 256.
Okay.
Okay. Implementing procedures. I was hoping that I would cover more space, but clearly I still have a lot more to cover. I'm trying to go over some of these things slowly and emphasizing certain aspects, because most of these concepts are general to different programming languages. So you're going to find that even when you're learning Java, there'll be error handling concept, the similar, not exactly, but they'll be similar. The constructs, you'll find that even in Java or in this JavaScript or PHP or C#, they have those constructs. There will be else, if-else construct, there will be a case construct, there will be a while construct, although some are going to even have something like do while this is true, or for this value, as long as this is this, you keep looping. So these are concepts that are going to be fundamental to most of the courses that you are going to do, which have to do with programming. Okay, let's see how far we can go. I have about 5 minutes. Let me just introduce stored procedures, then we'll come and continue next time. A stored procedure is a pre-compiled object stored in the database. So you can have a number of SQL statements. Those are going to be pre-compiled. I think I did talk about compilation and interpretation in the last lesson.
Yes.
Okay, so when we say compiled, we're saying the source code, that is the statements that you write in Management Studio, are translated into machine language, into a language that can be processed by the processor on your machine and stored in a form of a special executable file. Okay, the difference between a compiled language and an interpreted language is that a compiled language will take, when you have finished coding, writing the codes, you then compile it so that you create a special executable file, which when you run it, then the commands are going to be executed. Interpreted languages, are the ones where they'll be taking one line of your code and translating it into what the computer can understand at a time. So it will be one line at a time, one line at a time. If you come to a point where you have an error, then it will stop. But meanwhile, it would have executed the lines which are on top. That's not the case with compiled. Compiled languages is everything is put into one execution plan.
Okay.
So the batches that need repeated execution can be saved as stored procedures. So there isn't much difference between a batch and a stored procedure. The main difference is that a batch is a temporal, is a temporal set of SQL statements. And a stored procedure is where you have saved it so that whenever you need to execute those statements, you just refer to them by name. And this is a more efficient way when you come to programming, whether it's you can write a program in maybe PHP, a website, which will be retrieving information from a database. Instead of executing statements every time you maybe are searching something from the database using the website, you can create a stored procedure so that it will just execute the commands which are already stored as a compiled file.
Okay.
Now, stored procedures can be invoked by data definition language or data and data manipulation language statements. I hope you still remember the difference between these two or what they mean. Data definition language, we're talking about the statements which are used to create the structure of the database, such as create table, create database, create view, create constraint. Then data manipulation, we're talking about the statements that are used to manipulate information such as updating data or deleting data in the table. So we are saying that stored procedures can be used by any of these statements. And some of them can return a value. Some, they will just be able to execute something. Others, they will return the results back to the program. I need to stop here. Any questions? Quick question of less than a minute.
No questions, sir.
Okay.
Yeah, it's actually, yeah, today's lesson was very clear.
Okay. If you have any questions, just send them on the WhatsApp group, then we'll discuss.
Yeah, just in
Okay,
case
sir.
something comes up.
Okay. All right.
Thank you very much, sir.
Okay, sir. Thank you so much.
You're welcome.
Oh, sorry, sir. Just a quick question.
Yes.
You mentioned something. You mentioned something of. Okay, it's out of our topic though. Out of what we're from learning. You said we students who are doing infrastructure